Okay, I think we're up and running. This video is going to be based on the idea of MATLAB variables. So if we open up MATLAB, we can see that the big window that we have right in the center is our command window. This is what we will use for a calculator. For example, I could do 3 times 4 if I want, and MATLAB will calculate that for us. We can access help files here. So if I were to do help followed by some MATLAB function, maybe factorial is the first one that came to mind, it'll pop up and tell us what that code is doing and how you would do it. So we can go ahead and access help files from that. And additionally, this is where we'll see the outputs of our code. We'll get to that shortly. Other things that we currently have access to are the current folder. This is where MATLAB is looking. That is based on this link right here. If you ever wanted to change that link, you can go ahead and browse for the folder and go somewhere on your computer to find it. And if you selected a new folder, it would show up here, the contents of that folder. The last thing that we have in the bottom left is the workspace. The workspace is where the variables created are stored, where we can see the values of the variables and what the variables are called. That's really important when we think about the idea of assigning variables, which is the introduction to MATLAB. So what I'm going to do, and I'll do that again just to show you, under the Home tab, if I click New Script, that will pop up the editor window. You can see the word editor right here. And this is where you can write your longer codes. So let's say I wanted to create a variable. I'll call it X, and I will assign that to a number, maybe 2. Now you'll see this little squiggle underneath because the squiggle is going to tell us that if we want to hide the output, we can add a semicolon. You see how the squiggle disappeared, the warning. But if I didn't have the semicolon, I can run this and it'll show up down here in the command window. If that semicolon was there, and then I run it, nothing comes out of the command window because it's suppressed. That's what the semicolon does. Another thing to note is that after you run the code, you will see that the variable X is over here in the workspace. Its name is X, and its value that it is assigned to is 2 based on this code. This will update once a code is done completely running. So if I were to do X equals 6, I will clear all my variables. The only variable I have right now is X. I'll just clear that. So if I search fresh, CLC stands for clear command window. So that clears that entire window. Now it's clean. So if I were to run this, X will be assigned to 2, and then immediately after be assigned to 6. So if I run this, you'll see that the final value of X when this code run is 6 because of the fact that this is overridden. You can even see that here, the value assigned to the variable might be unused because of the fact we immediately overwrite it. Now, if I were to use that variable for some reason, like that warning went away. So let's think about what's happening. Let me do a different number. Let's say it's that. X is 2 for this when the code starts. Let me go ahead and clear the variables again. X is 2 when the code starts. The next line will go ahead and take that current value of X, which is 2, and then compute Y. So in this example, Y will end up being 8. Then at the end of the code, we'll go ahead and assign X to 6. We'll replace the value of 2. So if we run this, we'll see that X is 6. That's from this last line. And Y is 8. And it's important to note that we'll always compute the right side first of a line of code where we have an equal sign because of the fact we need to calculate this first before we assign it to the variable. So if we know what X is, it'll take the current value of X, which in this case was defined above, in order to compute what the value of Y will be. Now, the thing that trips people up is the idea of telling the computer that X is 3 and then saying that X is equal to X plus 1. Because when we see this mathematically, if you were to write this on paper in a math course, you would have people looking at you like you were crazy because of the fact that X is not equal to X plus 1. But in coding, X will be assigned to the value of X plus 1. So let's not use X yet. Let me just call this value. So X is 3. the right side of the code will be looked at first, and it'll take the current value of x and then add 1 to it. So in this case, that'd be 3 plus 1. We'll see that when we run this, the value ends up being 4. Now, it does not matter what this is called over here, as long as it's an acceptable variable name with no special characters or periods or numbers starting it or spaces or any of the things that we've talked about in class. As long as it's an acceptable variable name, that name will just take on the value of whatever's computed on the right. So if I run this, you can see that this value of FAS whatever is 4. Also note that the value variable, the one I called value previously, is still here because of the fact I haven't cleared anything. It will just save. I can replace this a bunch of times. I don't know, tree. If I run that, you can see that all these variables are here and they're all assigned to 4 because every time we run the code, it'll take x, make it 3, and then do something with it and assign it to this new variable. So it doesn't matter what I put here. So if I put x, let's hide this. Let me put my face over this. We'll hide that. I'm going to clear everything. I hope you can see my face over this. What we'll do is we will take the current value of x, which is 3, add 1 to it, and assign it to whatever's on the left. And in this case, we'll see that it ends up being assigned to x, meaning that we will overwrite whatever the current value of x is. So let me do this in sections. Remember that two percentage signs will create different sections of code. You can tell by the blue line here that that is a section. You can do that, run this section specifically by clicking this blue line or by clicking run section at the top. So if we were to do that for this section, we see that x is 3. Now, if I run this new section where I have x is assigned to x plus 1, what MATLAB will do is it'll take the current value of x, which is 3, add 1 to it, and replace its current value. So if you look at the workspace, you'll see that x is currently 3. If we run this section, look over here on this side, we'll see that x will jump up to 4 because we have just replaced it. If I were to run this code from scratch, and I click run, the whole thing will run, it'll make x 3, and then it will increase it by 1. So our answer won't actually change. It'll stay 4. But maybe I'll delete this for a second. What's interesting is that I've deleted this. This is my code at the moment. But x is defined. So x is currently 4. Maybe I'll unsuppress this so we can see it in the command window. If x is currently 4 and I run this code, it'll take the current value of x that's in memory, in this case that's a 4, and add 1 to it. So if I run this, we'll see that x becomes 5. If I run it again, x becomes 6. I just keep clicking. It'll just keep going up because every time it's taking the current value of x and adding 1 to it. So we see in the situation, the current value is 11. Based on the workspace, I'll add 1. If I run this code, it'll go to 12. And that's exactly what's happening when we do variable reassignment. Let's do another example. Let's say that y is equal to 6. We'll say that y is equal to 2 times y. Then we'll say that y is equal to y minus 4. I'm just making up things. So let's think about this. We start with y is 6. We will then go ahead and take that current value of y. Let's split this into sections so we can compare. If we run this section of code, we see that y is 6. We can see that in the workspace. If we run this section of code, we'll take the current value of y and multiply it by 2. That'll give us 12. We see that here. And we can go to the last section of code, and if I run this section alone, we'll take the current value of y and subtract 4 from it, and that'll ultimately give us 8. And if I were to run this code in its entirety, which is what run would do, would run all the sections. If I click that, we'll just see that the final value was 8. It'll just skip all those steps and tell us what the final value is. What's interesting about sections in MATLAB is that you could run them in any order you want. So maybe, let's say I wanted to run this one first. What would happen? Well, it would look to see what the current value of y is. And if you look at the workspace, there is no current value of y. If I'm only running this section and I run that, it's going to be confused and say, what is y? Because I haven't run this one yet. So the order of where you run things matters. So let's say I run this one first. We ran this one second the first time we did it. We got 12. What if I run this one first? Well, if I run this one first, we'll take the current value of y, which is 6, subtract 4. If we run this, we'll get 2. Then if I run this one last, for whatever reason, it'll take the current value of y, which in the workspace is 2, and multiply it by 2. We get 4. Typically, you wouldn't do this out of order thing unless you're troubleshooting or wanting to calculate a specific value. But the thing to remember is that the value that you use on the right side of the equal sign will be the value that is currently in the workspace. And that's what you'll use to compute things when you're coding. I hope this video was helpful. If you have any questions, please let me know. Thanks.